can write as fn equals fn minus 1 plus 2. So this is just example. It's not like generalized formula. Generalized formula is right here. Okay, so the second part is fn equals fn minus 1 plus 2. So 2 is the common difference, and then f1 minus 1 is the term before fn. So fn, like this is second term, you have to know the first term plus d. That's what this formula is saying. To generalize the formula, here's the recursive formula. f1 is k is the first term, and then fn equals fn minus 1 plus d, where n is greater than 1. Just think about it. When n is 1, so n is 1, right? f0 plus d. But in the sequence, there isn't a 0 term. It starts from the first term, so it has to be greater than 1. So it starts at 2, n equals 2. Okay, let's move on to geometric sequence. Geometric sequence is a sequence with a pattern that multiplies a number from the previous term to the next. So for example, 2, 4, 8, 16, 32. We multiply 2 every time. So we call this number 2 a common ratio. For the previous sequence, arithmetic sequence, what did we say? Common difference, right? Which is D. For common ratio, we are doing R. Let's practice. Tell whether each sequence is a geometric sequence. For each geometric sequence, find the common ratio. So I'll give you some time and then pause this video and then just solve for your own, and then I will solve together later. Okay, -1, comma, -1, comma, -1, comma, -1, dot, dot, dot. So for geometric sequence, we have to have a common ratio. So for this sequence, we multiply 1 every time. So R is 1. So this is a geometric sequence. I'll write it again here. R equals 1. The answer is geometric sequence. The common ratio is 1. Next problem. 1, 0, -1, 0, 1. So we have to multiply 1 to 0 and 0, right? And then 0 to -1. That doesn't make sense. So this is not a geometric sequence, and we don't have a common ratio. Okay. So like the arithmetic sequence has an explicit formula, geometric sequence also has an explicit formula and recursive formula. The explicit formula for geometric sequence is Fn equals K times R. So Fn equals K times R to the n minus 1 power. So first term is K and the common ratio is R. Pretty simple, right? Like similar to arithmetic explicit formula. Okay. Recursive formula, we are saying that f of 1 equals K, Fn equals Fn minus 1 times R, where n is greater than 1. So for example, if you want to know second term, you have to know the first term and then the common ratio. You have to multiply the first term with common ratio to get the second term. So let's practice together. Find an explicit formula an or fn for the following geometric sequence. 1, -6, 36, -200, and 16. Okay, we have to find first the first term, which is 1. And then the common ratio is -6. And then we can write this is explicit formula. So if we go back, this is the explicit formula. So first term times common ratio power n minus 1. Okay. So f of n equals first term 1 times common ratio -6 to the n minus 1. So for this, 1 times -6 to the power of n minus 1, you don't need 1 because 1 times something is, so 1 times 5 is 5, so we don't need 1. So for the final answer, it should be Fn equals -6 to the power of n minus 1. So this is the practice problem for explicit rule and one term. Okay, we can do it together because this is a unique problem. So this is you have to recognize that this is a geometric sequence because there is a common ratio 3. Okay. So the term is 648. You have to know the position, which is n. And term is an, right? Or fn. So we have to plug in 648 equals 8 times 3 to the n minus 1. So if we divide by 8 each side, this is 81. This is 3n minus 1. So 81 is 3 to the 4th. This is 3n minus 1. So 4 equals n minus 1 from the exponent. This is exponent rule. N is 5, which is fifth term. Here's the answer. Here's the homework questions. There are 4 questions. So for description, this question include real-life problems for arithmetic and geometric sequence. If you're stuck, go back to arithmetic and geometric sequence definition and description. Okay, so this 4 is like real life situation. If you read, like, there's a bacteria, like ball, like the paper. So yeah, I uploaded the answer. Let's see. So here's the answer. So this is the speaker notes. So I will upload the presentation slides later, so you can see that, and you can solve first and then see the answer to see if you're right. Okay. So for summary or reminder, you have to know the 4 formulas: arithmetic, explicit, recursive, and then geometric, explicit, and recursive formulas. You have to memorize it, but it is important to understand how formulas are made before memorizing. So you can go back to this video and then see how does it work. Okay. Okay. This is the end of the slides of the sequence. So I hope good luck in the study, and then I will see you next time.